Section 8.2, we are going to get into rectangular form and polar form of complex numbers. So let's think about the x and y axis that you're used to, where the x is going to be like the real axis, the y is going to be your imaginary. So if you had 2 minus 3i, you would go 2 over to the right and down 3, and that would be a representation of 2 minus 3i. So let's move down. It's also called the rectangular form. Now, if you're adding two complex numbers, so we know that if you add them, you add the real parts, you add the imaginary parts, you get 5 plus 4i. Graphically, if we have 1 plus 3i over 1 up 3, there's 1 plus 3i is that blue line. This one is 4 plus I. And then if you do parallel lines, so see this parallel dotted line is parallel to that blue one, this one is, and where they meet is the sum 5 plus 4i. If you were adding 6 minus 2i plus negative 4 minus 3i, you get 2 minus 5i. Same idea. You have your two blue lines, you go parallel to those, and wherever that meets, you get the answer. So now the trig or polar form shows that x is r cosine theta and y is r sine theta. R is equal to the square root of x squared plus y squared, and tan theta equals y over x. Those are all some relationships among x, y, r, and theta. So the expression, the trig form, is r parentheses cosine theta plus I sine theta. Sometimes that is abbreviated with r cis theta. So those are the same things. Now that we know what the polar form is and the rectangular, we need to go from one form to the other. So if we're going from trig to rectangular, so if I have 2 cosine 300 plus I sine 300, so we have to remember and look at our reference or figure out that cosine 300 is 1/2 and sine 300 is negative square root of 3 over 2. So if you put those values in, 2 times 1/2 minus I times square root of 3 over 2, you end up with, when you distribute that to 1 minus I square roots of 3. So the real part is positive and the imaginary part is negative. That's consistent with 300 being a quadrant 4 angle. All right, now if you were doing that in your graphing calculator, you would get 1 minus 1.73 blah 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 I. So that's like the square root of 3. Square root of 3 is 1 point. So you can do that on the calculator, but you need to have your answers in radicals. Now, if we're going from rectangular to trig, that's the difference. So if we had negative square root of 3 plus I. So you want to always start by graphing that, sketch the graph of that. So we don't know exactly what negative square root of 3 is, but we know it's this direction. We know it's this way, and that it was up 1 unit. So this is negative square root of 3 plus I. So we're in the second quadrant. So we know that tan theta is y over x. But before we do that, let's do r. R is the square root of x squared plus y squared. So plug in your x value, which was negative square root of 3, and your y value was 1. You get square root of 3 plus 1, that's square root of 4, so r is 2. Then we know tan theta is y over x. That was 1 over negative square root of 3. We're going to rationalize that, and we get negative square root of 3 over 3. Well, if tan is that, the reference angle for that is pi over 6. But because we're in quadrant 2, and that's really, really important, it's 5 pi over 6. So you have 2 as your r, cosine 5 pi over 6 plus I sine 5 pi over 6, or 2 cis pi over 6. So we now have a method to go from trig to rectangular and from rectangular to trig. So let's go look at the problem set. All right, number 1 says write the complex number in rectangular form. So this is in trig. We just have to remember that cosine of 45 is square root of 2 over 2, and sine is the same thing. So we have 14 times square root of 2 over 2 plus I square root of 2 over 2. So the 14 is getting distributed both places. 14 over 2 is 7, so we have 7 square roots of 2 plus 7I square roots of 2. That'll do that one. Write this one. Cosine of 240, I sine 240. Well, that is the cosine of 240, which has 60 as a reference, is 1/2. And sine is square root of 3 over 2. So we've got 12 times negative 1/2 plus 12I. Oh, I've already distributed there. Sorry. Didn't realize what I had done. So 12 times negative 1/2 plus 12I times square root of 3 over 2. 12 divided by 2 is negative 6 plus 6I square roots of 3. All right. 5 cis 45, so that's the same as 5 times cosine of 45 plus I sine 45. We plug in our square root of 2 over 2's, and we have 5 square roots of 2 over 2, because we did this, and 5I square roots of 2 over 2. Same thing with number 4. The cosine of negative 60 is positive 1/2. The sine of negative 60 should be negative. Yes, that is negative right there. So this should be 2 minus 2I square roots of 3. All right, you have to be careful with those signs. I missed that when I did it. Number 5, write the complex number. So 3 plus 3 square roots of 3I. So the first thing you want to do is sketch. So we know it's a positive 3 and then up 3 square roots of 3. R, square root of x squared plus y squared. So I plug in both of those. I've got 9 plus 27 when I square that. That's 36. So my R value is 6. Tan theta is equal to y over x. So 3 square roots of 3 over 3, which is square root of 3. And the angle that has a tan of square root of 3 is 60 degrees. So you've got your 6 that goes out front and cosine 60 plus I sine 60. Same thing with this one. You want to sketch it negative square root of 3 plus I. So we have negative square root of 3. Plug in and you end up with R is 2. Tan theta is negative 1 over square root of 3. You're going to rationalize. You have square root of 3 over square root of 3 multiplying. So you get square root of 3 over 3. The tan that has that is a 30 degree, but you're in the second quadrant, so that makes you be at 150. Number 7. Negative 2 plus 2I. These all seem to be in the second quadrant. So we're here, we plug in our values, we get an R that's the square root of 8, and you want to think of that as the square root of 4 times the square root of 2. Square root of 4 is 2, so you actually have that. Tan theta is 2 over negative 2, that's a negative 1, and the angle that has a tan of negative 1 is 45, but you're in quadrant 2, so that's a reference, and that becomes 135. Number 8, our last one. This one we have to use the calculator to get part of it. R is square root of 2 squared plus 3 squared, so that's 4 plus 9. So R is the square root of 13. tan theta is equal to 3 over 2. We don't know that. So in your calculator, second tan 3 over 2, you get 56.3. They said to round to the nearest tenth. So your angle is 56.3. And I think that'll get you going, changing from one form to the other.